Hello friends. So in continuation with previous video, we had the anchored bulkhead and the total height of this sheet pile is 6 meter as shown over here. And we need to find out the depth of embedment and the force in the anchor rod. The given data are phi equal to 30 degree, and above the water table gamma value is 20 kilonewton per cubic meter, and below the water table the submerged unit weight is given as a 10 kilonewton per cubic meter. This is the water table. It is at a depth of 2 meter from the top of the backfill. So at 2 meter, there is a water table. So in the previous problem, there was no water table. So we need to find out the depth of embedment and force in the anchor rod. So this we have to find out. We have to find out this. So it is the whole given data are similar to the previous problem, same, and let us find it out. The first thing is the active pressure at 2 meter from the top. So find out the value of P2. The active pressure at 2 meter, let's say it is P2 or PA2, must be equal to K times gamma T into 2 meter. And K is 0.33, 1 by 3, and gamma T is given to you as 20, and this is given as, so this gives you 13.33 kilopascal. This becomes, so if you draw the pressure distribution diagram, you can see that the pressure here is P2 equal to 13.33. Now below the water table, the active earth pressure P at 6 meter, that is here, because the total height is 6 meter, and the anchor rod has been provided at 1 meter from the top of the backfill. So P6 value, you can find it out. It will be 13.33 plus K into gamma prime into 4 meter. So this becomes 13.33 plus 0.33 into 10. So the value, you can calculate it, and this comes out to be again 13.33. That means it becomes 26.66 kilopascal. So the value P6 equal to, so it is total, this is going to be P6 equal to 26.66. And then the pressure here is going to be passive, and this is going to be active. So this is the active pressure. Now the value of A also between 0.6, and this, if it is A, B, you may call this point as C. So the value of A, C to 6, it is going to be A. A must be equal to P6 divided by gamma prime into K prime, where K prime can be calculated. K prime becomes Kp minus K. This becomes 2.67. So you can calculate 26.66 divided by 10 into 2.67. This is almost equal to 1 meter. So this is going to be equal to 1 meter, A equal to. And this value at point B is going to be K prime, gamma prime, and if this distance is y, so into y. So if you calculate it, 2.67 into 10 into y. So this becomes 26.7 y. So therefore, the value of Rp you can find it out. The force, the passive force Rp, you can calculate. So the passive resistance Rp will be given by 0.5 half into base. Base is 26.7 y multiplied by height, that is y. So this value, if you calculate it, you will find out the value of Rp also. So Rp can be found out. This becomes half of this becomes 13.35 y square. So friends, 13.35 Rp, 13.35 y square. So that is the value of Rp. Now, let's find out the magnitude of PA. So area of this active earth pressure distribution diagram from A to C can be found out, and you can calculate the area quite easily and find out the value of active thrust. So we need to find out the magnitude of the active thrust. This will be half into 13.33 into 2. This is, let's say this is P1, and plus the second area is a rectangle, that is 13.33 multiplied by 4. Let's call this as P2. So 13.33 into 4. Now this is the third one. So plus half into base, that is 13.33 into 4 plus this one. This is P3, and this becomes half into base is 26.66 into A, that is 1 meter. So if you, let's say this is P4, so you have got 1, 2, 3, 4. So this gives you the area. Summation will give you the value of PA. So let's calculate the value of PA. So we can calculate. This becomes 13.33 plus P2 becomes 13.33 into 4. This becomes 53.32 plus this is 2 into 26.66 plus this is going to be half of this. So 13.33. So if you sum up, 106 point. So PA therefore equal to 106.64 kilonewton per meter length of the sheet pile. So you have got the value of PA also known to you. Now you can find out this because moment is to be taken about the anchor rod. An anchor rod has been provided at 1 meter. Let's say this is Z bar. In the previous problem, what we have done, we have found out Y bar up to here. And then with respect to this, we could find out Z bar. Or directly you can find out the value of Z bar. How will you find out this Z bar? So Z bar will be P1 Z1 plus P2 Z2 plus P3 Z3 plus P4 Z4. All distances to be taken with reference to the anchor rod. So with reference to the anchor rod, you can find out Z1, Z2, that is the point of application of P1 with respect to the anchor rod is Z1 divided by P1 plus P2 plus P3 plus P4, that is PA. And if you calculate this, so all values are known to us. So if you calculate the value of Z bar is easily calculated as 3.13 meter. So friends, we are in a position to find out the value of Z bar. Z bar here is 3.13 meter. So Z bar is also known to you. Now what you can do is to take the moment of all the forces about the anchor rod. So algebraic sum of all the forces about the anchor rod equated to 0, and that will give you the value of Y. So now what we need to do is, RP is already known to us. So first of all, it is 13.35 into Y square. So let's take For equilibrium condition, sigma m about the anchor rod must be equal to 0. And therefore, if you take this one, then 13.35 y square, and the distance between the anchor rod and the line of application of RP, you can find it out, is going to be from here to here 5 plus 1, 6 meter, plus 2/3 of y. So 2/3 of y. So what we have to do it is 13.35 y square into 6 plus 2/3 means 0.67 y. This is going to create about this point a moment anti-clockwise, and then you have got the another force, that is PA, active thrust, which will be creating a clockwise moment, hence minus 106.6 into Z bar. So Z bar is 3.13, must be equal to 0. And you can easily solve this equation. And solving this, we get y. So this y value, you can calculate it. So this, if you multiply this and this will be y cube. So 13.35 13.35 into 0.67, 8.94. So 8.94 y cube plus 13.35 13.35 into 6 gives you 80.1 y square minus 106.6 into 3.13 equal to 333.65 equal to 0. So now this is the polynomial equation, and this equation on solving this cubical equation, polynomial equation, the value of A is known to you, B is known to you, D is known to you, and therefore this gives you the value of y. So therefore, on solving, we get the value of y equal to 1.858 meter. Therefore, this depth of embedment D equal to y plus A. A is 1 meter, so this becomes 2.858 meter. So depth of embedment is for factor of safety, this is for factor of safety equal to 1. So you increase it by 30% to provide the depth of embedment. So depth of embedment provided, D, which is to be provided, will be 1.3 times of D, and this you can calculate it. So D provided is 3.72 meter. Friends, this is one part of the answers for factor of safety equal to 1.5 to 2. You should multiply it. It should increase the value of D by 30% to 40%. So you have got the value of D. Now, in order to find out the value of FA, that is the force in the anchor rod, can be easily calculated by equating sigma Fh equal to 0. So algebraic sum of all the horizontal forces must be equal to 0. So Fa must be equal to Pa, that is 106.6 minus this Rp. Now, what is the value of Rp? You calculate Rp. Rp is given as 13.35 y square. 13.35 y square. So the value of y, you can substitute it and get the value of Rp. So this comes out to be the value is 46 kilonewton. So the value of Rp being known to you, 106.6 minus 46.08. The value comes out to be 60.52 kilonewton. So this value of Fa is known to you, the second part. So both Fa 60.52 kilonewton and also the value of Rp we have calculated. Fa is known, D provided is known. So D provided here is 3.72 meter. So all the values are known to you. So this is the solution of this problem. So friends, the effect of water table I have shown you. In the previous problem, it was completely dry. There was no water table. Here we have taken the water table and you can see the difference in the pressure distribution diagram. Thank you very much.